I tried to build an lasted AI in League of Legends, but how does it even work?
In the game of League of Legends, one of the core and crucial skills is last-hitting minions. To acquire gold from the minions in the game, you should give the killing damage.
Imagine if you could automate this, and while you are focusing only on the enemy champions, the AI handles the rest. First, let's think about we as humans are using from the game view to make the last hits. Let's stop here. I divide the process into 3 parts. First, we detect each minion and their health bars. And although it feels very intuitive for us, actually there is also a process to match health bars to correct minions, especially when they are in front of each other. After this step, we observe remaining health of each minion. And lastly, we are deciding whether to hit any of the existing minions and clicking the corresponding pixel. Now let's see how these human steps correspond in the AI system. We will have in-game screenshots as input to the AI. And we want the system to produce an output as the pixel coordinate to which it's going to click to last hit. We have 4 different modules or steps to make this happen. The first one is object detector. We will detect both minions and health bars on the given input image. The second module is Minion Associator. After detecting minions and health bars, we need to match them. The next module will calculate the remaining health of each minion. We need this because the decision of hitting a minion is of course based on the health level. And lastly, we have to come up with a logic to decide whether a minion will die if we hit it, and if it's the case, which pixel to click. In the end, we will achieve the desired output.
After recording some gameplay, we will annotate detection boxes on the in-game frames. And the reason is, to be able to kill minions, we will first need AI to detect health bars and the minions precisely. We won't need extensive amount of data since we will utilize a pre-trained detector and fine-tune it for our needs. Once the annotations are complete, we need a detector model to train. For this project, we are going with YOLO V9. YOLO V9 is a state-of-the-art object detection algorithm renowned for its speed and accuracy in identifying objects within images and videos. After arranging our dataset and installing YOLO V9, we are ready to go with the training. After a couple of hours of training on Google Colab, let's see the results. So, as you can see, both the average precision and recall are more than 96%. However, we see that the recall of the health bars aren't as good. The reason is, it's easier to miss them since they are so small. But let's see the performance of the detector on a gameplay recording. So, in general, it works pretty fine. But there are some misdetections, for example, this flower, and sometimes it can't detect health bars for some frames. And especially when there are some animations like this, it can also tends to not be able to detect some of the minions or health bars, but in overall it seems pretty fine and it is ready to go.
Now that we are able to detect minions and health bars separately, we need a way to associate them, or we need a way to match correct minions to correct health bars. And the first thing that comes to mind is use the intersection between them. But we need a more sophisticated way than just looking at the intersections one by one. To emphasize this, I'll stop the video here and take a look at this frame. Let's take this 4 minions. The minions and their health bars are detected using the object detector. And I will tag the bounding boxes to clarify possible confusions. The logic is to find the intersection percentage between health bars and minions to make a matching based on this percentage. But we can see some minions are intersecting with multiple health bars. I create an intersection matrix with the minions on the columns and the health bars on the rows. Now we are going to fill the matrix with the intersection amounts. Let's take a look at this example to understand how the calculation is made. We see that this minion's bounding box intersects with two health bars. The computation is really simple. We take the intersection area and just divide it to the whole health bar area, and do the same calculation for the other health bar too. If we do this for all the minions, we get such a result. Now, the naive approach would be going minion by minion and match them with the one it intersects the most. The process is like this. We look at the percentages of the first minion and match it with the highest one. And do the same thing for the second and the third one too. But when we come to the last minion, the only remaining unmatched health bar is actually the wrong one. And this is just a result with 4 minions. The problem will exponentially get worse as the number of detections increase. The reason behind this naive approach wouldn't work is there are a lot of occlusions and the object detector doesn't work perfectly. So we need a more advanced algorithm, and this is where Hungarian matching algorithm comes in. The Hungarian algorithm solves this by finding an optimal way to pair elements of two sets, maximizing the total score of the assignments. In other words, the current pair of assignments have a total score of 2.89. But the correct matching is actually scored as 3.81, and Hungarian algorithm optimizes on top of this total score. Here we will use template matching. Template matching is a technique in image processing for finding small parts of an image which match a template image. Now let's think what is the indicator small part of an health bar image to get the remaining health. It is the intersection point of the health level to the background of the health bar. If you take this part of the health bar and run the template matching algorithm, we will find this intersection point, and if we divide this part's length to the whole health bar length, we can find the remaining health level of that minion. And as we develop the Minion Associator and health level calculator, this is the result we are getting. You can see minions, their types, and the remaining health level percentage. We have now everything to make the last hitting decision. We have to answer 3 questions for the hitting decision. First, when to hit a minion. Second, which minion to hit. And third, which pixel to click. Although it looks straightforward, we can easily overcomplicate things here. For example, to answer the first question, we actually should also take into account that the speed of which the health levels of minions decrease. Or we should know the exact location of our champion to decide which minion to hit. But I tried to go with the simplest approach for each of the questions. The answer to the question of when to hit a minion is when the minion's health is equal to our attack damage. Health of a minion is equal to its health level times total health of that minion type. The aim is to find when this equals to our attack damage. We can calculate health level, and we know minion types from the result of object detection, so we know their total health. If we give attack damage to the AI, we are done. Now the problem is what to do when there are more than one minion with low enough health and AI decides to hit them. It is actually a very complex question, but I make a very simple decision here. If there are multiple options, just click the closest one. And lastly, how to define the exact pixel location for AI to click. We will just take the middle of the bounding box. So the testing will go like this. As the gameplay goes on, whenever AI decides to hit a minion and clicks a pixel, I will mark that location. But note that this gameplay is the one I played. There is no automatic last hitting at this moment. This is just a visualization. You can see the blue markings that show the pixels where the AI made the final hitting decision. However, since we didn't take into account the champion's attack speed,
and didn't put a delay between attacks, the AI spams the point that needs to be clicked. To solve this problem, I implemented attack speed logic into it. And this is the result we are getting after that. Now you can see yellow indicator markings every once in a while. I noticed a couple of minor potential bugs due to the health load calculator not working at perfect precision. But let's try this in a live game. Okay, I entered the practice tool. I'll test the AI. So it will go like this. I just move around the mid lane and won't click or hit any of the minions. And let AI handles the hitting part. And we'll see how many minions, how many CS we will have in 10 minutes. I have some concerns generally about latency. I think it won't perform fast enough, mostly because of the object detection. Yeah, there are some more problems we will face, and I will talk about them later on. Now let's focus on this test. And yeah, they're coming. Let's see. I close the auto attack setting. And yeah, let's see. I'm not doing anything right now. I let the mouse go. It got one. One still. Still one. Okay, yeah. Nice. Okay. Okay. Yeah, 5 out of 12 at the moment. It's so close every time. Yeah, okay, let's fast forward until minute 10. Okay, we are getting to the minute 10. We have 44 CS at 10 minutes. It is roughly 40% of the total minion count. Without changing anything else, I just want to increase attack damage and remake this experiment again. Okay, our attack damage is now roughly 200. It was around 80 before. Yeah, minions are coming and I let go the mouse. Let's see. The reason behind this setup is just to see how well the object detector performs. High attack damage removes health level calculation issues from the equation. It basically just tests the object detection and click accuracy. Okay, at the 10 minutes mark, we have 69 CS. It is roughly 65% accuracy.
This is how the interpretation of the AI looks like. The first thing that catches the eye is how low the FPS is. This is actually the biggest reason why it performs relatively poorly. The computer I am currently using does not have a GPU. Therefore, the forward pass of the object detector takes an average of 0.15 seconds. This causes the AI to run at about 5 FPS in a game where I normally get over 100 FPS. The second big problem is object detection results. We see that it misses minions in many frames, which makes it impossible to make a last hit. There are actually two main reasons for this. The first is the low health bar recall. If you remember, we had an average recall of 0.85. This means that we won't be able to detect minions roughly 1/6 of the time. When we combine this with the low FPS issue, it misses lots of last hits. As a solution, I can buy a GPU and make the 250 sample dataset, which is actually quite small for such a task, much bigger. And if I do that, I'm pretty sure that the accuracy will be over 90%. So if a sponsor who wants to get out of the bronze comes along, I can continue the project. However, at this point, I do not want to do neither of them. For now, it was enough for me to prove that this was possible. The only thing that left for me to say is, thanks for watching.